Welcome to this session. This session, we are going to do an example on how to solve a system of differential equations, or simply to solve the system x dot equals to ax with some initial condition given. So solve the initial value problem, x dot equals to. So the matrix is A is a 2 by 2 matrix with element 6, 8, minus 3, minus 4. And then this is the initial condition given. Now let's discuss the solution. So our matrix A is given by 6, 8, minus 3, minus 4. So first step, we find eigen values for the matrix A. So i.e., solve the equation A determinant of A minus lambda I is equals to 0. This is a characteristic equation. Now, A minus I, determinant will be the same as 6, 8, minus 3, minus 4. Now, minus lambda. So, I is determined by the order of the matrix we're dealing with. Because it's a 2 by 2, so we need an identity of 2 by 2. So, which will give us 6, 8, minus 3, minus 4, minus, so lambda multiplies everything. Yes, we'll have lambda 0, 0, lambda. And then next step, we'll have, now if you are subtracting two matrices, then you subtract component wise. So we'll have 6 minus lambda, 8 minus 3, minus 4 minus lambda, determinant equals to 0. Now this will be 6 minus lambda times minus 4 minus lambda. Now minus minus is plus, 3 by 8 is 24. And then this will be minus 24 minus 6 lambda plus 4 lambda plus lambda squared plus 24 equals to 0. Now minus 24 plus 24 cancels out. So we'll have lambda squared minus 6 plus 4 is minus 2 equals to 0. And then we factorize this quadratic. So we'll have lambda into lambda minus 2 equals to 0. So this implies lambda 1 equals to 0 and lambda 2 equals to 2. So after getting the eigen values, next you get eigenvectors. Now, let's start with the first one, lambda equals to 0. Now, because we are dealing with a 2 by 2 matrix, so our eigenvectors will be having this form, x1, x2 in 2 dimensions. So we know that the matrix equation eigenvector eigenvalue is of the form A U. So because we are dealing with lambda 1, we say A U1 equals to lambda 1 U1. So that is the eigenvector eigenvalue equation. So we'll have our A matrix is 6, 8, minus 3, minus 4. Now we let this one to be our u vector. So I'll have u1 vector, so x1, x2 equals to lambda 1 is 0, and then x1, x2. Remember, x1 and x2 are the unknowns for us to solve, and they're just real numbers. So let's carry out this multiplication. So I'll have 6x1 plus 8x2, and then minus 3x1 minus 4x2. This is what we get on the left-hand side. Should give us 0 by x1 is 0, 0 by x2 is 0. Now, for this equality to make sense, the first row must be the same. So 6x1 plus 8x2 should be 0, or the second row and the second row, not or, should also be the same. So call this one equation 1, call this one equation 2, and equation 1 and equation 2 are the same. So because if you divide through by 2, you'll have 3x1 plus 4x2 equals to 0. Divide through by minus 1, you get the same thing. So from 2, we say x1 equals to minus 4x2. So which tells us that x1 is the same as minus 4 over 3 x2. Or in the same language of saying x2 is the same as minus 3 over 4 x1. So the same thing. So which means if we set x1 to be t, then x2 will be minus 3 over 4 t. So which means my u1, which will be x1, x2, will be given by x1, which is t, and x2, which is minus 3 over 4 t. And you see, I can decide to do away with fraction. Then for me to get a whole number here, I need to multiply by 4. So this is the same thing as saying 4, say k, minus 3k. So where k is the same as 4 40, or simply use the same t. So this is the same as writing 4 minus 3 k. Thus, when you set k to be 1, then u1 will just be 4 minus 3. So that is our first eigenvector. So which means x1 solution is given by e raised power lambda 1 t. This by definition will be given by e raised power 0 t, and then 4 minus 3. So which will be e raised power 0 is just 1, so the same as 4 minus 3. Now let's go to the lambda 2. Lambda 2 was given by 2. So let U2 be the eigenvector. So it means that you'll have a U2 equals to lambda 2 U2. And because we are dealing with a 2 by 2 matrix, then U2 can be written as, say, U1, U2, or you can even use X1, X2. So that have A is 6, 8, minus 3, minus 4. And then U1, U2 equals to lambda 2 is 2. And then U1, U2. So that's what we have. Now carry out the multiplication. So we'll have 6U1 plus 8U2, and then minus 3U1 minus 4U2 should give us 2U1 and then 2U2. And for this equality to make sense, then the first rows must be the same on either side, and also the second rows must be the same. So 6U1, this implies, plus 8U2 should be 2U1, or the same thing as saying 4U1 plus 8U2 equals to 0. And this other one will be minus 3. So call this one equation 1. U1 minus 4U2 should be 2U2, or say minus 3U1 then minus 6U2 equals to 0. Just take this one to the left. Now this one equation 2. Now from 1 and 2, so from 1, we can divide through by 2. We have U1 plus 2U2 equals to 0. And you should see the same is the same thing as what we have in the second, which is that U2 is the same as negative a half U1. So which means that if we let U1 to be, say, T, then U2 will be negative a half T. So the vector U2, which is given by U1, U2, will be T and then negative a half T. And then be the same as saying 1 minus a half, and then T. Remember, this T can be any non-zero real number. So if we let T to be minus 2, or that's just a specific example, then I'll not have these negatives. Then U2 will give me negative 2 and then 1. So this is my U2, which implies x2 of T by definition is e raised to power lambda 2 T U2 will be given by e raised power 2t, and then this minus 2, 1. So that's what I have. Now, the solution, the general solution, by superposition principle, is simply the linear combination of the x1 and x2. So is x of t equals to c1 x1 of t plus c2 x2 of t, i.e. x of t is c1, and then the solution for x1 from our calculation was given by 4 minus 3 plus c2, this our x2, we write it as minus 2, 1, and then e raised power 2t. So now to get the correct or the actual values of C1 and C2, we use the initial condition. So remember, we are told that x of 0 is given by the equation we had x of 0 is 1, 2. So x of 0 means that when you replace 0 for t, this is what you get. So this implies C1 4 minus 3 plus C2 minus 2, 1. So where this t you put 0 should give us 1, 2. So then 2 times 0 is 0, so e raised power 0 is 1. So just have 4c1 minus 3c1, and then plus minus 2c2, and then c2 should give us 1, 2. Now this would be 4c1 minus 2c2 minus 3c1 plus c2. This would give us 1, 2. And for this equation to make sense, then first row should be the same and second row should be the same. So 4c1 minus 2c2 equals to 1, and minus 3c1 plus c2 equals to 2. So this equation 1, this equation 2. So these are simultaneous equations in C1 and C2. So from equation 2, C2 is the same as 2 plus 3C1. So we can substitute that for C2 in the first equation. And so we have 4C1 minus 2 into 2 plus 3C1 equals to 1. So 4C1 minus 4 minus 6C1 equals to 1. So we'll have minus 2C1 equals to 1 plus 4, which is 5. So it tells us that C1 will be minus 5 over 2. And so C2 will be 2 over 2 plus 3 times minus 5 over 2. It will be 2 minus 15 over 2. And 2 minus 15 over 2 gives me minus 11 over 2. So therefore, x of t will be C1, which is minus 5 over 2. Then that vector was vector for 4, negative 3, plus C2 is minus 11, over 2. And then we have minus 2, 1, e raised power 2t. And we can actually simplify further this. I say this is the same as, so minus 5 over 2 times 2 is minus 5. And then this will be plus, because here we have now minus minus, so 11 e raised power 2t, and then minus minus plus, so 15 over 2, and then minus 11 over 2 e raised power 2 t. So remember, this is negative, so 2, so this negative 10, not 5. Negative 10 because we have minus 5 over 2 times 4. So 1, 2. So minus 5 times 2 is minus 10. So this is minus 10. So that will be the solution to that given problem. Thank you.